All right, students. Okay, so today we're doing 11.9 representation of power series. Which basically we're going to take a power series and we're going to be able to write it in different forms or find an expression and rewrite it in a power series form. So let's recall this expression that we talked about in 11.8. We have this expansion 1 plus x squared plus blah, 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 which essentially is the sum n equal to 0 to infinity of x to the n power. And we realized when we were doing this that this is an infinite geometric series, right? And so because it's an infinite geometric series, we use the formula a divided by 1 minus r. You don't have to write all of that. And when we did that, we came up with this expression. 1 over 1 minus x, because we realized that x was our r. That is our r. And this works as long as the absolute value of our x, which is the same as r, is less than 1. Okay? So now, we need to work with this so that we can deal with other expressions and be able to write them in a power series form. So here is our first example. The example says, express 1 over 1 plus x squared as the sum of a power series. So what we want to do is, what we want to do is we want to try to match it up to this form or this form. Okay? So what we can do, I can rewrite it in a form like this, where I can subtract an r. My a would be 1. And if I want to subtract my r, then I can rewrite it like so. I can take 1 over 1 plus x squared, and I can rewrite it so that I subtract negative x squared. And negative x squared is then my r. So I can rewrite it like that. And now I have my a, and now I have my r. And so, therefore, using this and using this formula and knowing that this generates this, I can rewrite my expression like this. This guy is equivalent to the sum of negative x squared to the n. All we really did is match this up with this first power series expression. And this was my x, so x to the n. So now my r is negative x squared, and we're taking that to the n power. Okay, so we're just playing around with the form that it's in. Okay? So that's the answer to the question that I highlighted. Okay? Now, if they ask us, which this one didn't ask, but if they ask us for the radius of convergence, since we know that this is an infinite geometric series, then we know our r has to be less than 1. Okay? So if our r is less than 1, I'm going to take negative x squared and make it less than 1. Which, in other words, if I do absolute value, that's going to be x squared less than 1. So when is x squared less than 1? On this interval, negative 1 to 1. So my radius of convergence is 1. And then my interval of convergence is negative 1 to 1. Now here, I don't have to use a I don't have to test my endpoints like we did yesterday when we did the ratio test, because since we're treating this like a geometric series that converges, it will only converge if my r is less than 1, not equal to. There's no inconclusive situation here, okay? If I wanted to check to see if this converges and I didn't use this, but I used the ratio test, then of course, if I use the ratio test, I would test both of my endpoints and find out, and then I will find out that if they were equal to -1 and 1, that it would end up diverging. Okay? Questions? All right then. All right, so now let's do another problem. So, same type of question, different problem. Express this as a power series. So remember, we want to kind of match it up with this guy. Now, this time in my numerator, I have an x cubed instead of 1, okay? So I would like to get a 1 there. So I can factor that out. Okay, so I can have that. Now I'm going to work with this part of my expression. So for me, it's a little confusing with my x being here. I would like my x to be in this spot. So I did this, and then I switched it around, and then I factored out the 2. So I switched those two, and I factored out the 2. The reason why I factored out the 2 is because I wanted to get a 1 in this spot. So when I factor out a 2, I'm going to have 2 times the quantity 1 plus x over 2. Now I can factor out that 2 and make a 1/2. Oh, watch, I didn't here, but. And then I can turn this into a minus x over 2, which is my r. And then I put it over here. I took out the 1/2. So now I have x cubed over 2 times 1 over 1 minus negative x over 2. So this is my infinite geometric series part. This is that. These are factored out of that. So I am going to use what I normally use for the sum, my power series, and then I'm going to multiply that by this expression here. So that is what I did here. I factored out the x cubed over 2, and then I took my r, which is negative x over 2, and I took it to the n power. And I rewrote it like so. Now on the AP test, sometimes they'll have it in this form. Sometimes they will have it in this form. They are equivalent. What happened? We distributed this n. 2 to the n, x to the n, and there is a negative 1 to the n. Sometimes they will have it in this form. What did we do? Distribute this back in. So if I distribute this back in, it's going to be x to the n plus 3. And 2 to the n plus 1, because this is 2 to the first power. So if it's multiple choice, they might have it in this form, or this form. So we have to be flexible with that. Questions? Okay. Oh,